Hi students, good morning to all. Welcome to grade 11 business mathematics class. In the last class we have started our first chapter, matrices and determinants. In that you have learned how to find the minor and cofactors. Yes. So up to example 1.4 we have completed and I gave 2 homeworks to do. I hope you all completed. So let's start our today's section. First one is properties of determinants. Properties of determinants. There are few properties are given in your book that will help you to do the further problems. So first I will explain all the properties one by one. Listen carefully. All of you take your book page number 8. So, first property is the value of the determinant is unaltered when the row and column are interchanged. The value of a determinant is unaltered when its row and columns are interchanged. I will give one example for you, then only you will understand. That is first property. I am giving one example. A matrix is 1, 2, 3. Next 4, 5, 6, 7, 8, 9. So this is A matrix. Okay. So in this property they said the value of a determinant is unaltered when its row and columns are interchanged. Unaltered means it won't change. Okay. So if you are changing the row and columns, if you are interchanging row and column, the determinant value, it won't get changed. That's the meaning. Understand? So if I am changing all the row as column and column as row, the determinant value there is no change. Understand? So now it is determinant A means if I am taking this as determinant A. Okay? It's not matrix A, it is determinant A. If it is determinant A, when I am finding A transpose, so what will happen? Row will change as column is. So 1, 4, 7, 2, 5, 8. Next is 3, 6, 9. Okay. So same A is equal to A transpose. This is the first property. Understand? So the value of a determinant is unaltered when its row and columns are interchanged. When you are interchanging row and column, the determinant value, it won't get changed. That's the first property. Then second property is if any two rows or columns of the determinant are interchanged, then the value of the determinant changes only in sign. Okay. Any two rows or column. For that I am giving one example. Same example we can take. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now what they said, I can interchange any two row or column. So row or column I can interchange. So I am going to interchange R1 and R2. Okay. Properties are very very important for doing the next problems. Okay. So R2 in the place you are interchanging R1. R1 place I am interchanging R2. So 4, 5, 6, 1, 2, 3, 7, 8, 9. Understand? R2 and R1 I have interchanged. So R1 place R2, R2 place R1. In that case, you need to change a sign. So minus you need to insert here. That's the second property. Now read the property. If any two rows or columns of a determinant are interchanged, then the value of the determinant changes only in sign. Okay, if I am interchanging any two row or column, only there will be a change in the sign. Understand? Okay. Then third property, if the determinant has two identical rows or column, then the value of the determinant is 0. That is, the meaning is, if two rows are identical or two columns are identical, that is, if two rows having the same value, identical means same value. Okay. So last row anything. Okay. So 4, 5, 6. Now see here whether R1 and R2 are identical. Yes. R1 is equal to R2. So both the rows are identical means the value of this determinant is 0. Understand? This is the third property. What they said, if the determinant has two identical rows, that is two row values same, means we will say the determinant value is equal to 0. Understand? Next one is, if all the elements in a row or column of a determinant are multiplied by a constant k, then the value of the determinant is multiplied by k. For that I am giving one example. If all the elements in a row, so okay, I am taking 1, 2, 3, then 4, 5, 6, 7, 8, 9. If I am multiplying any of the row into 2, okay, I am going to multiply by a scalar. That is, first row, if I am multiplying by a scalar 2, so what will you do? Of a determinant or multiplied by a constant k, then the value of the determinant is multiplied by k. Okay, so when you are finding the determinant, you will multiply by the k. That is 2 you can take outside. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you will have a doubt. The 2 you have to count. I have taken 2 outside. How? You will have a doubt. The thing is, in the property they said, if in the first row the 2 is common, means also you will take the 2 outside. If in the second row 2 is common, means you can take 2 outside. Third row 2 is common, means you can take 2 outside. If any of the rows, if one particular term is a scalar, you can take that particular scalar outside. Understand? This everything you will use for problems. Okay. Next one. If any two rows or columns of a determinant are proportional, then the value of the determinant is 0. Okay. So proportional. Proportional means, so if any two rows of the determinant are proportional, then the determinant is 0. So same as this one only. So if first row it is 1, 2, 3, second row it is 2, 4, 6. Shall we take? So I am taking this matrix. Okay. So that is 1, 2, 3, 4, 5. Sorry. We can take 4, 5, 6. Sorry. 2, 4, 6. Okay. The next one is 7, 8, 9. I am taking like this means. Now I said this, right? In the fourth one. What will you do? You can take outside from the second row. That is 1, 2, 3. This is 1, 2, 3. This is 7, 8, 9. So this value also 0. That's a fifth property. Understand? So what they said, if any two rows of a determinant are proportional, then the value of the determinant is 0. So here in the second row, what is common? 2 is common. So 2 I have to outside. So all the rows you no need to check. If any one of the row, there is one multiplying by a scalar, you can take the common term outside. Then check it. 2 rows are proportional, so the value is equal to 0. Understand? Okay. Then next property is, if each element in a row of a determinant is expressed at the sum or more terms, then the determinant has been expressed as the sum of 2 or more determinants of the same order. Okay. So we can split. That's the meaning. So I will give another one example for you. That is 1 plus A, 2 plus B, 2 plus C, 4, 5, 6, 7, 8, 9. Now the given determinant is like this means we can split it as 2. How much? Plus before terms separately. 1, 2, 3, 4, 5, 6, 7, 8, 9. Center it's plus. Okay. So plus. The next one, next after the plus symbol. So what will happen? A, B, C, 4, 5, 6, 7, 8, 9. You can split it into 2 matrix. 2 determinants. This is the sixth property. Understand? That is, if each element in a row of a determinant is expressed as the sum of 2 or more terms, then the determinant can be expressed as the sum of 2 or more determinants of the same order. You can split. Okay. Then next one is 7th one. The value of the determinant is unaltered when the constant multiple of the elements of any row is added to the corresponding elements of a different row in a determinant. Okay. So the meaning is, I will give an example. That is 1, 2, 3, 7, 4, 5, 6, 7, 8, 9. So here what they are saying is, I can interchange this R1 as R1 plus 2R2 plus 3 R3. So this matrix, this determinant must be equal. If I am interchanging R1 as using this condition, means what will happen? R1 plus. So R1, in R1, what's the first term? 1, is it right? Then plus 2 into R2. Okay, so 2 into R2 plus 3 into R3. So if we are using this condition, and if you are simplifying the R1 and the R2 and R3 same, means also the values won't change. So these are the 8 properties. Understand? These are the things you need to take to the notes. You just go through. I gave all some examples to make this property as easier. Okay, but you need to learn the 7 property for doing the next problems. Okay, we will use this property for the questions. Example 1.5, show that x, y, z, 2x plus 2a, 2y plus 2b, 2z plus 2z. A, B, C is equal to 0, you need to prove. Now we are going to use the property. That is, I explained in property number 6. What is 6th property? You refer in your book. If each element in a row of a determinant is expressed as a sum of 2 or more terms. So sum of more 2 terms means then the determinant can be expressed as the sum of 2 or more determinants. I explained, is it right? So we are going to split this into 2. Okay. So how means solution? So this matrix, this determinant I am writing. X, Y, Z, 2x plus 2a, then 2y plus 2b, then 2z plus 2c, a, b, c. Okay. So first and last one as it is, x, y, z. Second one I can split, is it right? 2x, 2y, 2z, a, b, c plus, you need to write it in same line, okay? X, y, z. Second term is 2a, 2b, 2c, a, b, c. Okay? A, B, C. Correct? Then I said in one property, if any one of the scalar is common to any one of the row, we will take that as outside. Okay. So here in this determinant, what's the common? 2 is common. So x, y, z. Second one, x, y, z. A, B, C. Same as that, here also what is common? 2 is common. So x, y, z. Then next one A, B, C. Next one A, B, C. Understand? Now you come to the another one property. We have learned another one property. If any 2 row or column are identical, what's the determinant value? The value is 0. Yes. So here now see, that is 2 into this 2 rows are equal. Same as that, here also these 2 rows are equal. So 2 into 0 plus 2 into 0. The answer is 0. Now it's proved. Understand? So we are using in this question 3 properties. First, what you did? Using the 6th property, we have split this into 2 terms. Next, what we did? If any one of the row is multiplied by a scalar, we will take that scalar outside. Okay? I took the scalar outside. Then when we are seeing that particular determinant, any 2 rows are proportional or identical. Then that particular value is 0. So when you are multiplying time, you will get 0. This only we need to prove. So this is our answer. Understand? Example 1.6. Evaluate x, x minus 1, x plus 1, x. Okay. This one no need to change anything. Directly we can find the determinant. Okay, so cross multiply and center we will put the minus symbol and we will do. So how we will do? That is equal to, we will cross multiply, is it right? So that is x, x plus 1, x minus 1, x. Okay, is equal to, just you cross multiply, x into, that is from here to here. Okay, so x into x is x square minus of, center minus, okay, minus of x minus 1 into x plus 1. Okay, that is equal to x square minus, you can keep outside. First you multiply this 2. X into x means x square plus x minus into plus 1 is minus 1. So that is equal to plus x and minus x will get cancelled. So how much you will get? X square minus x square minus 1 into minus means plus 1 you will get. So this and this will get cancelled. You will get the answer as 1. I will repeat. that is x minus 1, x plus 1, x. Okay, so just you will cross multiply. So x into x means x square minus of x minus 1 into x plus 1. So you will multiply here. So x into x is x square, x into 1 is x, minus 1 into x is minus x, minus into plus 1 is minus 1. So this and this will get cancelled. X square minus, multiply with minus, so you will get the answer as 1. Understand? Okay. Then next one is example 1.7. Solve x minus 1, x minus 2, 0, x minus 2, x minus 3, 0, 0, x minus 3 is equal to 0. Okay. So there one note is there in your book. Nearby this question one note is there. I wrote here. That is the value of the determinant of triangular matrix is equal to the product of the main diagonal elements. Okay. So in the note they said that is it's a triangular matrix. Correct? I have explained what is mean by triangular matrix. I said, is it right? It's the leading diagonal. That is it's the main diagonal. From it's a main diagonal, below all the entries are 0 or above all the entries are 0. Here below all the entries are 0. So you know it's a triangular matrix. So it's the triangular matrix is equal to the product of main diagonal elements. So is equal to the product of main diagonal elements. Okay. So main diagonal elements, what are the main diagonal elements? X minus 1, x minus 2, x minus 3. So we are going to find the product of this 3. Okay. So x minus 1 into x minus 2 into x minus 3 is equal to 0. So how we will do? X minus 1 is equal to 0, x minus 2 is equal to 0, x minus 3 is equal to 0. From that x is equal to 3 values you will get. What are the values? 1. Here if you bring means 2. Here it is 3. So x is equal to 1. X is equal to 2, x is equal to 3. Very simple. We are using the note. Understand? That is the product of the main diagonal. That is the value of the determinant of the triangular matrix is equal to, already in the question it is given, the value of the determinant is equal to 0. Okay. So the value of the determinant of the triangular matrix is equal to the product of the main diagonal elements. So product means main diagonal elements x minus 1 into x minus 2 into x minus 3 is equal to, this is the value of the determinant is equal to 0. Each and every term you will equate to 0. From that x4 you will get 3 values. Understand? Okay. Let's move to the next question. Example 1.8. Evaluate 1, 3, 4, 102, 18, 36, 17, 3, 6. Okay. So when we get this question, first you check it, is there any common? Okay. First I am writing the question. 1, 3, 4, 102, 18, 36, 17, 3, 6 is equal to. So listen here. 1, 3, 4 as it is. Okay. So I think in the second row one common element is there. So 36 means 6 is common. 18 means there also 6 is common. 102 shall we check? 6 means here 42, again it's also common. Okay, so 6 is common. So you can take the 6 outside by using the property. By using the property I have explained, be thorough in the property, then only it will be easy for you to do. Okay, so when you are taking this common outside, please write down the particular property on the side. Understand? Then only you won't forget. When you are revising for the exams, you won't forget. Okay. So please write down whatever the property we are using for each and every questions. Understand? So here what is the common? 6 is common. That is fourth property we are using. That is, if all the elements in a row of a determinant are multiplied by a constant k. So here the constant k is 6. So 6 if I took outside means 1 or 2, what will happen? What is balance? 17 you will get. Here it is 3, here it is 6. Again this one 17, 3, 6. Okay. Now see this determinant, whether R2 and R3 are identical. R2 and R3 are identical. This is identical symbol. Okay. Identical. That is equal. So whether R2 and R3 are identical? Yes. Is it right? If two rows of a determinants are equal means what will you say the value is? 0. Understand? You need to write the property on the side. Understand? So any two rows of a determinant is equal means we will say the determinant value is equal to 0. So for this problem you are using two property, that is multiplying by the scalar, that's the fourth property. Then any two rows are proportional, that is fifth property. So two properties also you want to write on the side. and write down the answer. Understand? Okay, let's move to the next question. Example 1.9. Evaluate 1a square, 1b square, 1c square is equal to a minus b into b minus c into c minus a. It's an important question. It's an important 3-mark question. Understand? Solution. I wrote the question. For this question, what we are going to do in the sense, that is, we are going to change the R1 as R1 minus R2 and the R2 as R2 minus R3. I said in the last property, is it right? So, what I am going to do, I am going to change R1 as R1 minus R2 and R2 as R2 minus R3. So, R1 minus R2 means this is R1, this is R2, okay. So, this row fully you want to subtract with this row. So, 1 minus 1 means what will happen? 0. Then, A minus B, is it right? A minus B. The next one, A square minus B square, correct? Yes. Then, R2 how will you change? Change R2 minus R3, is it right? So, 1 minus 1 is 0. Next is B minus C. Next is B square minus C square. Last one is as it is, 1C C square, okay. That is equal to 0, A minus B. You know the formula for A square minus B square. What's the formula for A square minus B square? A plus B into A minus B. So, 0, B minus C, B square minus C square means B plus C into B minus C, 1C C square. Understand? Then, that is equal to, already I said, is it right? If any any one of the column or row is there, any term is if anywhere it is common means we will take the common outside. Okay, so I am going to take this A minus B and B minus C outside. So what's the balance? 0. This A minus B I have took outside, so it will become 1. Here A minus B I took outside, so A plus B will get. Then here it is 0, B minus C already I took outside, then B plus C will get 1C C square. Understand? I took the common outside. Okay, I took the common outside. Understand? I explained everything in the property. Understand? So next, that is equal to A minus B into B minus C. You keep this outside, then find out the determinant value. So how you will find the determinant value? 0 into this and this will get cancelled. So what's the balance? 1 B plus C, C square. Okay. Then minus 1 into, then this and this will get cancelled. So 0 into 1 B plus C square. Okay, correctly do it very carefully. This and this will get cancelled. So 0, 1 B plus C square. The next one is plus A plus B into this and this will get cancelled. So 0, 1, 1C. Okay. Understand? Then that is equal to A minus B into B minus C. This one you keep it outside. Then 0 into this value. So anyhow this determinant fully it will become 0. Then minus 1 into 0 into C square means 0. Minus of B plus C. Correctly. Okay. Then plus A plus B into, then 0 into C means C minus 1. Sorry, 0 into C means 0. 0 minus 1. That is equal to A minus B into B minus C into the 0 we can leave. That is with minus you need to multiply. Okay, before that minus 1 into minus B minus C. Then plus A plus B into minus 1. Okay. So then that is equal to A minus B into B minus C. Multiply with this minus, what will happen? B minus into minus plus C. Same as here also. If we multiply means what will happen? Minus A. Plus B into minus 1, what will happen? Minus B. So plus B and minus B will get cancelled. So what's the balance? A minus B into B minus C into C minus C. This only we need to prove. Understand? Very, very important question. Again I am repeating, listen here carefully. First I am changing R1 and R2 using this and I interchanged, and afterwards A minus B and B minus C is common. So I took the common outside. Then A minus B into B minus C is outside. Then you are going to find for the across the first row. Okay. that is c, 0, 0 into this and this will go 1c, b plus c, c square you will get. Then next term means minus. Always you keep it in mind, this for plus, minus, plus, again minus, plus, like that alternatively it will come. So that is, then find the determinant value and carefully you simplify, you will get the answer. Very, very important question. Understand? Okay, first section, examples, everything over. Let's move to the exercise. Exercise 1.1, problem number 1 and 2, already I gave homework for you. Then same as that, next your home assignment is 3 and 4 to practice. Okay, third problem and fourth problem. Just I am explaining, that is third question is simply solve. Okay, same as this problem. Okay, then fourth question is find determinant AB. For that you need to find the AB first. AB you know to find. Last year we have found out. Is it right? AB means using 7 method you will multiply. So A into B. Afterwards for that AB, that is product of A into B, you will find out. Afterwards that AB for you find the determinant value. That's the answer. Understand? Okay. Now let's move to the fifth question. So your home assignment is exercise 1.1, problem number 3 and 4. Okay. Now it's fifth question. Solution. So 7, 4, 11, minus 3, 5x, minus x, 3, 1. So we are going to expand the given determinant along R1. Okay. So how we will do? 7 into this and this will go. So how much will get? 5, 3, x1. The next number minus. I said, is it right? So this and this will go. So what's the balance you will get? This and this will go means minus 3, minus x, x1. The next number 4 plus 11 into minus 3, 5, minus x, 3. Okay. So is equal to 0. Already it's given. That is equal to 7 into 5, 1 is 5, minus 3x, then minus 4 into minus 3 into 1 means minus 3, minus of minus plus x square, plus 11 into minus 3 into minus 3, sorry, minus 3 into plus 3, minus 9, minus of minus plus 5x. Okay, is equal to 0. That is equal to 7 into 5 means 35, minus 7 into 3 means 21x, then minus into minus plus 12, then minus 4x square, then minus 99 plus 55x is equal to 0. I multiplied it. Okay, that is equal to, now you collect all the like terms, 4x square. Then what about the x term? This and this one. So minus 21 plus 55. So if we simplify, how much will get? Minus 21 plus 55. So plus 34. Correct? Then plus 12 plus 35. So plus 12 plus 35 means 47. 47 plus is minus 99 is there. Is it right? So how much will get? 35 plus 12 means 47. 47 minus 99 means we will get minus 52 is equal to 0. Okay. So we can divide this by 2. Okay. So you will divide by 2. This is minus 4x square. Is it right? So you will divide by minus 2. This everything you have learned in lower classes. Because of that I am moving faster. So if you divide by minus 2, what will happen? 2x square is 2x square plus 17x. Then minus into minus we have to go outside. So plus 26 is equal to 0. Now you factorize. You know to factorize. 2 into 26 means 52 you will get. So multiplying times 17 you need to get. Is it right? So what are the numbers? Find out the numbers. The numbers are 13 and 4. Okay. So how much will get? 13 plus 4, 17. Multiplying time 52. So split it. So this everything you have learned. 2x square plus 4x plus 13x plus 26 is equal to 0. So 2x is there. So you will get x plus 2. Then same as plus 13 you will take outside. So x plus 2 is equal to 0. So 2x plus 13 one value. Another one value x plus 2 is equal to 0. Is it right? So what's the x value? X is equal to minus 13 by 2. Another one x is equal to minus 2. Sorry, x is equal to 2. Okay. So here it is minus. Okay, sorry, minus. It is, then will be t minus. Is it right? So what will happen? Here it is minus. Here also it is minus. Okay, sorry. Minus. Okay. So plus 4 minus plus, sorry, it is minus. divide this by minus 2. So what will happen? 2x square plus will change as minus, is it right? So minus 17x plus 26 is equal to 0. Okay, there is a change in the symbol. Okay, so 52. So again I am doing 52, then it is minus 17. So 13, 4, both also minus. Okay, so how much? 2x square minus 13x minus 4x plus 26 is equal to 0. Okay, then how much will get? Here x is common, so 2x minus 13. Then here minus 2 is common, so you will get 2x minus 13 is equal to 0. So x minus 2, another one, 2x minus 13 is equal to 0. So x is equal to 2, another one, 2x is equal to 13, which implies x is equal to 13 by 2. So what are the values? X is equal to 2 or x is equal to 13 by 2. Understand? So x for 2 values. Understand? This and all I not explained the details. Why means in 9th standard onwards you know. Okay. So if it's a quadratic equation, how to factorize and find the x values. That's all. Understand? So for this problem, first we are expanding the determinant along the R1. That's the only difference. Afterwards, for that you will get one quadratic equation. If you are obtaining one quadratic equation, how to solve a quadratic equation? If you are solving a quadratic equation, you will get x for 2 values. That's the answer. Understand? I gave already 2 home assignments for you. Problem number 3 and 4. Understand? So this is a 5th question. So from in the next class, we will start from problem number 6. So in the just I am giving a small recall for your today's class. That is, first I have explained 7 properties. Be thorough in the 7 properties. I explained by using all the examples. You go through that. Please children take notes. Take in your notes, please copy all the 7 properties first. Copy all the 7 properties. Afterwards, example 1.5, 1.6, 1.7, 1.8, like that you copy. Afterwards, copy from this notes, and afterwards do the home assignments. In the next class, we will start from the exercise 1.6, 1.1, 6th problem. There are three more problems left. We will see in the next class. Understand? I hope you got a good idea in the properties of the determinants. Very, very important section. Go through, learn it. Don't leave anything. Thank you, students. We will meet in the next class.